You probably use it every single day in your video calls, your online games, maybe even in some secure file transfers. It's this amazing technology that promises a magical, direct connection between any two browsers on the entire planet. But if you've ever actually tried to build with it, you know it's not magic. It's a beast. And that's what we're talking about today, WebRTC. The entire story of WebRTC, all of its complexity and its brilliance, it all boils down to this one, seemingly simple question. If my browser wants to send video directly to your browser, how in the world do they find each other and just start talking? The answer to that is the key. It's how we're going to understand both the dream and the notorious difficulty of WebRTC.
And this right here, this is the dream. Just imagine a web where you could communicate with anyone instantly. No plugins, no downloads, no having to use proprietary apps like Skype. Just the raw, incredible power of real-time communication built directly into the fabric of the web itself. That was the revolutionary vision from, wow, almost a decade ago.
So yeah, let's start there. Let's start with that powerful vision. What was WebRTC really supposed to be? Okay, so at its core, WebRTC is basically a set of open standards and JavaScript APIs. You've got getMediaUser, which is what lets a website ask, hey, can I use your camera and microphone? And then you have RTCPeerConnection, and that's the real workhorse. This is the piece that's supposed to do all the heavy lifting of connecting you directly to another person. The whole goal was to make real-time communication a native part of the web, just as normal as, say, an image or a block of text. So that was the dream, right? But then developers actually tried to build with it, and they ran headfirst into a very, very different reality. As developer Hussein Nasser puts it so well, the experience of learning WebRTC is often just frustrating. Not because the technology itself is bad, but because all of its complexity is hidden behind this wall of really shallow explanations. And that brings us to the second part of our story, the developer's journey. It's all about how that simple, beautiful dream crashes right into a surprisingly complex reality. So you start out with this simple goal, right? You just want to connect two people for a video chat. But you almost immediately get dragged down into this rabbit hole of acronyms and concepts that, let's be honest, most web developers have never had to think about in their entire careers. It feels like hitting a brick wall of networking mumbo-jumbo. And frankly, it's where a lot of people just throw their hands up and give up. So here's the real puzzle. If the idea of a peer-to-peer connection is so straightforward, why is this one of the hardest technologies out there to get working? Well, the answer lies in a fundamental problem with how the modern internet is actually structured. WebRTC's biggest hurdle isn't the tech itself, it's the architecture of the very internet it has to operate on. The main villain in our story is a technology that, ironically, makes the internet work for all of us, but completely breaks the simple dream of WebRTC. It's called NAT, or Network Address Translation. Think of it like this. Way back in the 90s, every computer might have had its own public street address, but we ran out of those ages ago. So today, your entire house gets just one street address. That's your router's public IP. And all your devices inside, they just get room numbers, like the bedroom or the kitchen. NAT is basically the doorman for your building who figures out which room a piece of mail is actually for. So let's just trace the path here. In step 1, your computer sends out a request from its private address, its room number. Your router intercepts it. Now in step 3, it swaps out that private address for its own public street address. And here's the really crucial part. Step 4, the router makes a quick note in its little logbook, the NAT table. It does that so when a response comes back, that doorman knows exactly which device, which room, to forward it to. And this is the absolute core of the problem for WebRTC. Your computer is totally hidden behind this wall. It has no idea what its public street address even is. So if it wants to tell another browser, hey, connect to me, what address can it possibly give? This is the exact puzzle that WebRTC was designed to solve. It comes with a whole special toolkit designed specifically to get past this NAT wall. So this toolkit has two main parts. First, there's something called a stun server. Its only job is to be like a mirror. It just sits there, and when your browser asks, it says, here's the public address I see you coming from. Simple. Second, you have a turn server. Now this is the expensive backup plan. If a direct connection just isn't possible, a turn server acts as a middleman, relaying every single piece of data. Don't worry about the acronyms, just remember their roles. Stun is the scout, and turn is the heavy-duty escort. Okay, so how do you manage all this? That's the job of another piece called ICE. The best way to think about ICE is as the conductor of an orchestra. It uses stun and turn to discover all the possible ways to connect. Your private address, your public address, maybe that relay address. These are called ICE candidates. And then it very intelligently figures out the best, most direct path that will actually work. Okay, so now we have the tools to punch a hole through that NAT wall. But that leads us to the next big question, right? How did two browsers exchange all this information in the first place, like their ICE candidates? This is where we get to what I like to call the secret handshake. And get this is the part that feels a little weird. To set up a communication channel, you need an existing communication channel. It feels like needing a phone to call someone to ask for their phone number. You have to solve the problem before you can solve the problem. Like Nasser says, it feels a little bit silly when you think about it. So the information that needs to be exchanged is packaged up into something called SDP. The absolute best way to think of this is like a digital business card. It's just a big old block of text that says, hey, here is everything you could possibly need to know to connect with me. All my possible addresses from ICE, the video formats I can understand, my security info, the whole shebang. Now, the process of actually swapping these digital business cards is called signaling. And listen up, because this is the key part that trips up so many developers. WebRTC intentionally leaves this part out. It does not care how you get that SDP from peer A to peer B. It's on you, the developer, to build this messenger service yourself, usually with something like WebSockets. Okay, deep breath. Let's put all these pieces together. We have NAT, stun, turn, ICE, SDP, and signaling. I know it's a lot, but when it all works, you get that incredible peer-to-peer payoff. All right, here's the final dance. Peer A starts everything by creating an SDP offer. That's its business card, and sends it over your signaling server. Peer B gets it, then it creates its own answer card and sends that back. Once both sides have successfully exchanged their information, ICE has everything it needs. It tests all the possible paths it discovered, and boom, it establishes the best, most direct connection possible. And what's really amazing is just how often the simplest path actually works. According to data from early WebRTC apps, a direct connection can be made using just a cheap stun server about 86% of the time. That really expensive turn relay server, it's only needed as a fallback in roughly 1 out of every 7 calls. So after all that complexity, what's the big payoff? Why does any of this matter? Well, because a direct peer-to-peer link gives you the absolute lowest possible latency, which is critical for gaming or live video. It gets rid of the server bottleneck. It's encrypted end-to-end by default, and it's all based on an open standard built right into the browser you're using this very second.
Which, brings us right back to the beginning. The dream of WebRTC is to enable a more direct, a more decentralized web, a web where our conversations don't always have to pass through some giant company's central servers. But to achieve that dream, you have to navigate this immense, hidden complexity. And so the real question for the future is this: is that payoff truly worth the price?